Okay, now we're going to go over section 5.6. And this is on dividing polynomials. Okay, and we're just going to go over dividing by a monomial. Dividing by a monomial. So if you had a plus b over c, that's equal to the same thing as a over c plus b over c. So you could take each term in the numerator and put it over the common denominator, like that. And then you could simplify, and we'd use our quotient rule to simplify, if we could. So let's look at this example. 12x to the fourth plus 3x squared all over x. Now, your first step is to rewrite that so that you have each term in the numerator over the common denominator. So put 12x to the fourth over x plus 3x squared over x. Now, you can combine these x's right here by subtracting the exponents using your quotient rule. And you're always going to put the x wherever the highest exponent is. So if the highest exponent is in the top, you're going to subtract the exponents and put the answer, put the x in the top. If the higher exponent were in the bottom, you would put it in the bottom. So here, everything's going to go to the top. So that would just be 12x cubed when you subtract your exponents, because you know that's x to the first on the bottom, and 4 minus 1 is 3. Plus 3, and the same thing here, you can put those x's together. X squared divided by x is just x. Subtract your exponents. This gives you x to the first, or x. So that's your answer there, 12x cubed plus 3x. All right, let's look at this one next. Negative 9x to the fifth plus 3x to the fourth minus 12 all over 3x cubed. Okay, your first step is just to write each term in the numerator over 3x cubed. So we'll put negative 9x to the fifth over 3x cubed plus 3x to the fourth over 3x cubed minus 12 over 3x cubed. And then we just simplify each term. Now that first term, negative 9 divided by 3 is negative 3. Okay. Now these x's are going to go to the top, and you're going to subtract. And the reason it goes to the top is because that's where your higher exponent is. 5 is higher than 3, so you know it's going to be in the top. So it's 3x, negative 3x squared. And you don't have anything left in the denominator. Plus, now on this one, those 3's cancel out. And the x's are going to go to the top, so that would just be x to the first, or x, minus, now on this one you can divide 3 into 12 and it goes 4 times. You can't do, there's nothing to combine that x with, so it's going to stay right where it's at. So it's just going to be minus 4 over x cubed. I want to do one more example. let's do 6a squared minus 4a plus 12 all over negative 2a squared. Okay, you know the first step is to rewrite each part of the numerator over the negative 2a squared. So we get 6a squared over negative 2a squared minus 4a over negative 2a squared plus 12 over negative 2a squared. Okay. Now this first term is going to be negative, and you know that 2 will go into 6 3 times, and the a squareds cancel out because they're to the same power. So that first term you just get negative 3. Now here on this next one, you see you have minus, and this fraction is going to be negative because you're dividing by negative 2 on the bottom, so you have minus and negative, so it's going to be plus. Anytime you have minus and negative, that's plus. And 2 will go into 4 2 times, and that 2 is going to go on the top because you're dividing 2 into 4, not the other way. Now your a's are going to move down to the bottom because that's where your higher exponent is. So you're going to bring the a to the first, you're going to kind of bring it down, bring the 1 down, and subtract it from the 2. So that would give you a to the first on the bottom. So that would be 2 over a. The 2 goes in the top, the a's are going to go down to the bottom, just subtract the exponents. 2 minus 1 is 1, so it's a to the first power. Now the last one, that term's going to be negative because you're dividing a positive by a negative, so it's minus. 2 will go into 12 6 times, and there's nothing to do with that a squared, so that would just be minus 6 over a squared. And that's all you do.